Okay, this would be Unit 1.3, Angle Relations. I have to be careful. I often write or spell angles into angles. So I'm sure the study of angles is very interesting as well. Anyway, an angle is formed by two rays with an endpoint, with a common endpoint, and this common endpoint is called the vertex. The rays are called the sides. And we often name an angle using three letters. In this diagram on the left, we would call it angle ABC, and the middle letter must always represent the vertex. Okay, that's important. In this specific angle, we can also just use the vertex letter, angle B, a single letter, to represent that. Note that we only do that, and we're going to see some examples later. We only use one letter when this angle cannot be confused with another angle. And when we measure how big or small the angle is, we use a small lower letter M. And so this reads as the measurement of angle ABC. Pay attention, this is an equal sign. We're going to talk about the difference between congruency and equality later. There we go. So let's see how we classify them. Let's go from the one on the right, which is easier. And this denotes a 90-degree angle, and you probably learned it in middle school. It's called the right angle. And this angle here is obviously greater than 90 degrees, and we call that an obtuse angle. And this one is less than 90 degrees, so we call that an acute angle. Okay? Now let's look at some examples. Name the vertex of the angle. In this case, on the left-hand side, this one would be K. That's the vertex. And the sides of the angle, we've got two rays. One is KL, written like that. One is KJ, written like that. Now give three ways to name the angle. So we can name it JKL with a K, which is the vertex in the middle, and we can do the other way, LKJ, it does not matter, and we can also just call it angle K. Now angle K, if we measure it from one side to the other, is obviously greater than 90 degrees. That would be an obtuse angle. Second example is slightly more complex, but if you're careful, you're going to get everything right. The vertex for angle 2 would be right in the center, and that's that big letter T. The sides for angle 4 is the two rays, TW and TZ. Another name for angle 3, there are different ways of doing it, but I would do UTZ. And for angle 1, I probably will pick YTX. And name the sides of angle 5, I would do TY, that's one ray, and the second ray would be TW, right? And classify angle YTW, I've got that right angle there, the sign that denotes right angle for angle 5. And YTU, and because angle 1 is 90 degrees, YTU is greater than that, so YTU has to be obtuse. And then angle XTU, XTU obviously is an acute angle. And the last one, WTU, is another obtuse one. Okay, if you have trouble understanding why they're classified this way, make sure to stop by and ask your questions. So that's how we classify one angle. We call it acute angle, obtuse angle, or right angle. Now, if we have more than one angle, these angles may have some relationships. So let's take a look here. Adjacent angle. Adjacent means next to each other. So that's an SAT word, I believe. And so all it means is that these two angles, angle 1 and angle 2, they share a common side. They have to share a common side. That's by definition adjacent because they're next to each other. That's what it means, that they share that black side. Okay? Complementary angles are angles that adds up to 90 degrees. So in this case, angle 1 and angle 2 adds up to 90 degrees. And what is this? Supplementary angles are two angles that adds up to, let me give you an example. Say this is 135 degrees, this one is 45 degrees. You add them up together, you've got 180 degrees. So those are supplementary angles. So any two angles, you add them up together is 180 degrees. That's supplementary angle. Note that complementary and supplementary angle do not have to be adjacent to each other. I drew two examples that are adjacent. However, here, a linear pair would be an example. Angle 1 and angle 2 are a linear pair because they are not only supplementary, they form a line, they also are adjacent. And that's why we call them linear pair. Okay? Finally, this is my favorite angle. Later on when we study other things in geometry, you will find this so handy. I call this scissor angles, but the official name is vertical angles. But it looks like scissors, right? So when we have two angles across from each other, say angle 1 and angle 2, they sit on intersecting lines, they are always congruent. So by the same token, angle 3 and angle 4 will be congruent because they're opposite of each other. They're vertical angles. Again, the congruency sign is there because we're talking about in shapes, sizes, in addition to angle measurements. Here are some examples. Number 1, the relationship of angle 1 and 2. They're obviously scissor angles, vertical. Number 2, they are angle 1 and angle 2 are also adjacent. They are also complementary because they add up to 90 degrees. Number 3, question number 3, they are adjacent angles. They are also supplementary because they add up to a line, and they are also a linear pair because they are right next to each other because they're adjacent. Number 4, they are adjacent, angle 1 and angle 2. I think that's it. There's no indication about complementary, supplementary, or linear pair. Let's do number 6 first. Number 6, 1 and 2, they are opposite of each other. They are vertical angles, right? They're scissor angles. And but they are also supplementary. Why? Because if this is 90 degrees, the angle measure for 1 must be 90 degrees. And if 1 is 90 degrees, then angle measure for angle 2 is 90 degrees. 290 degrees adds up to 180 degrees. By definition, they're supplementary. And number 5 is probably the most tricky. I want to point out this little tick mark here. This one and this one. By ticking that, it means that this angle, angle 1, and let's call this angle here, angle 3, are congruent. They're of the same size. Okay? I'm going to erase that just so that we can see better. I will do 3, angle 3 here. So, okay, we're asked to analyze angle 1 and angle 2. They're clearly not adjacent, but they're vertical. And note that it gave me more information with a tick mark, so there may be something else as well. Are angle 1 and 2 complementary? I'm not sure, but I know if this angle is 90 degrees, angle 1 and angle 3 must be 90 degrees. And so which means angle 1 is half of 90 degrees, so that's 45 degrees and 45 degrees here. If angle 1 and angle 2 are vertical angles, they are congruent, this must be 45 degrees as well. So angle 1 and angle 2 does add up to 90 degrees. Okay? They are not supplementary, they're not a linear pair. So that's the That's how we identify those angles. I think I'm gonna stop here for this unit. There are more than a couple of exercises for this unit. They're somewhat straightforward. Give it a try and let me know if you have any questions. Thank you, guys.